Suppose you have an equation which is in the following format. You have dy by dx, and then you have an x function and a y function together. In this scenario, what you can do is you can rearrange this so that you have 1 over gy dy and fx dx. So I've taken this to that side, and I've taken, let me just make that a bit bigger, this to that side. When I divide by gy, I get 1 over gy. When I times that by dx, I get fx dx. Okay, now I can integrate each side separately. And this is your differential equation. So if you have something in this format, your goal is to rearrange it so you have this format. And then you would integrate and simplify from there. So let me take you through this example. We have 1 plus x squared dy by dx equals x tan y. Okay, we want all the x's on one side with the dx. We want all the y's on the other side with the dy. If we divide by 1 plus x squared, we're left with x tan y over 1 plus x squared. And now if we take the dx to the other side, we're left with 1 plus x squared and then dx. The last thing that we need to do is move the tan y. So if we divide by tan y, we get 1 over tan y dy equals x over 1 plus x squared dx. Now we're in that format which we wanted to be in. From here, we can integrate. And we're going to integrate each one separately. Before we integrate, we can simplify 1 over tan. So let's make this cot y dy equals x over 1 plus x squared dx. Okay, from here, we're ready to integrate. And one rule that you're going to need to know is that the integration of cot x is ln sine x plus c. So, making use of that, can you integrate both the left and right hand side here, please? So, the left hand side would just be ln sine y. I'm going to get rid of this equals because we need one here. And then making use of the reverse chain rule, you would get a half ln 1 plus x squared and then plus c. Because you have, because you're integrating both sides, you don't need to have plus c on both sides. You only need it on one side. And usually that side is going to be the right hand side, so that your plus c is positive. Now, in this case, I have c, and then the other two terms that I have are ln, right? So what you can do is can rewrite c. Instead of using c, we can use ln k. C and ln k in this scenario are interchangeable, means the same thing. So now, if we use the log rules, ln sine y is equal to ln and then k root 1 plus x squared, because you're doing this ln plus that ln, which is the same as multiplying, and then this half turns into a power here, which is the same as root. Now, because it's completely simplified and there's ln on both sides, we can get rid of the ln entirely, and you're left with that. There you go. That is your answer. It says find a general solution to the differential equation. That's it. Done. Okay, I hope that made sense. Just a little recap. You want to rearrange so that you have all of y on one side with dy, then all of x on the other side with dx. And then you're going to integrate and keep simplifying until you can't simplify anymore. Cool. Question 4. I want you to do this one for me, please. Okay, so the first step is to rearrange so that all of y is on one side, all of x is on the other side. Okay, I'm going to start by factorizing the 2y plus 2yx. So 2y bracket 1 plus x dy by dx equals 1 minus y squared. Now I'm going to move the y squared. No, I'm going to divide by 1 over x. So dy by dx equals 1 minus y squared all over 1 plus x. That's what I've divided by the bracket on the left. Now, if I divide by 1 minus y squared, I get this. And now if I multiply that dx out, I get this. Now we're ready to integrate because you've got all of y on one side with dy, all of x on the other side with dx. Okay, in both cases, you're going to use the reverse chain rule. So making use of the reverse chain rule, you would get ln 1 minus y squared equals ln 1 plus x. This would be negative. Yep, and then plus ln k. Okay, from here, let's use our log rules. Using the log rules, we know that if there's a minus there, that means it's minus 1, which then becomes the power. And we know this positive really means multiply. So ln 1 minus y squared to the power of minus 1 equals ln k bracket 1 plus x. Okay, and let me do that. Now that we've simplified lns on both sides, we can get rid of it. So 1 minus y squared all to the power of minus 1 equals k 1 plus x. I can rewrite this as 1 over 1 minus y squared, k bracket 1 plus x. Now in the question, it said, given that x equals 0 when y equals 0. So let's plug that in. 1 over 1 minus 0 all squared equals k bracket 1 plus 0. So 1 equals k, which means 1 over 1 minus y squared equals 1 plus x. Okay, so from here, if we flip them both upside down, and now we move the y squared to the right and the fraction to the left, and simplifying that would give this, or you can have 1 plus x in the denominator, doesn't really make a difference. And now you root. There you go. That is your answer. So it says, give your answer in the form y equals gx. That is why I did this step. This is to get y from being a denominator to just being level. This is the final answer. Okay? That is differential equations.